Okay, here we are at site 9, our final site on the Anity Burn, and what we can clearly see is our river has now become very wide and in some areas reasonably deep, like at my feet, and about 250 meters downstream from here is the mouth of the Anity Burn, where the river joins the River Tay. And therefore we started at the beginning of today quite near the source, and we've come all of the way down to very near the mouth. Now, if we just reflect on what we're expecting to find here, and then have a think about what our results may be showing us, we would expect a dramatic increase in discharge from site 1, as predicted by Bradshaw. We would expect rocks in the river to have become quite small in size relative to what we saw at site 1. We would expect rocks to be far more rounded, and we would expect the efficiency of the channel or the river to be much more efficient than it was at site 1. Now let's just have a little think about our data. What does the discharge show? Well, the discharge will show that the river's probably still continue to increase. It's very clear where I'm standing that there's more water in the river than there was at the previous site, site 8. So why is the discharge increased? Well, there's been another few little tributaries joining the river. There's more water coming as through flows through the soil, down the valley sides, and percolating in from the surrounding rocks. Will the increase be as much as it was at maybe site 5 and 6? No, it's unlikely the river's yet recovered to the level it was at site 6. And that's because we're still in an area of sandstone rock. And I'm actually standing on some boulders of that rock, which means that water is continuing to be lost through percolation. If we think about rock shape, well, we can see our river is absolutely full of rounded material with very little angularity left in the river channel. There is obviously going to still be some rocks coming in from the valley side due to things like root wedging and freeze thaw, which break off the rocks and they roll down into the river. And they will lead to some angular rocks in our river, but the majority of rocks we can see are pretty rounded. Likewise, our average rock size is going to be pretty small. We can see that almost everything in this river is of roughly the same size, nothing much larger than a couple of handfuls in size. And therefore, there's very little you can say about rock shape or size. Efficiency, however, if you happen to be studying that, there's an awful lot you can say about efficiency. It's likely that our river is not as efficient as it was at the previous sites, that actually the efficiency has dropped. And the reason for that is that our river is now hitting quite a flat landscape. You can see that upstream it was fairly steep, and we can just see it coming down a steep little gradient there, but then it hits the little waterfall there and it flattens out over this period. Now that is because the river has got a floodplain on either side of it. The landscape's widening out. There is actually a geological change happening right at this point. And we're moving back to the harder rock. We're at an interchange between sandstone and the volcanic rock. Now, what does that mean? It means that the river's no longer cutting down into the landscape as much as it was. It's created a flat landscape either side. The river's spread out substantially. It's widened. And because it's widened, it's lost its efficiency because it's got quite shallow. At this particular location. Even though it's wide, it's shallow. That means that actually there's little depth and a lot of the water is coming into contact with the base of the river, which is slowing it down. And we can see certainly as it passes under the bridge there's quite a lot of friction from interaction with the rocks. So it's also on quite a flat gradient here, and the flatness of the gradient means that the velocity slows down, and that will in turn affect the efficiency of the channel because it's flowing slower. It's going to be less efficient at moving water. So that's our entire river from site 1 to site 9. If we reflect on what we've seen across this journey, the discharge has undoubtedly increased dramatically from the very small trickle we saw at site 1. However, rock size has also got smaller. It's likely our rocks are now much smoother, that the data would be showing us that, and that our river overall is more efficient now than it was at the start. Of course, it's not been a smooth change, and discharge, rock size, rock shape and efficiency have altered between site 1 and 9, and whenever they do something that you're not expecting where they maybe rise when you're expecting them to decrease, or when they decrease when you're expecting them to increase, that's where you need to offer your analysis.